All right, welcome back, everybody. So today we are going to just review the concept that we learned about yesterday with a little bit extra. We're basically finishing up the notes from yesterday first before we get to the new stuff. So we're going to be solving quadratic equations again, two different ways. This is where we left off yesterday. So here we go. First things first, we said one technique is to use factoring. So I want to show you this one more time since we didn't get a chance to go over it. So when we factor, here comes my two factors. There's my 0. We have an x squared, so we're going to split that off immediately right away. And then, of course, down here at the bottom, we're looking at our factoring, and we're thinking, what numbers multiply to give me that negative 18, and what two same numbers add up or combine to give me a negative 7. Now, we know that if this is a negative value that we're trying to get, then one of my numbers should be a negative. All right, so let's see. We're going to think about our numbers that multiply to give me an 18 off of our list. And we know that 9 and 2 are two numbers that multiply to give me 18. And when they subtract, it'll give me a negative 7. But because I'm trying to get a negative 7, we know the 9 should be the negative, and the 2 will be the positive to give me a negative 7. And of course, when we multiply them, we get a negative 18. So with that said, here come our two numbers, negative 9, positive 2. We officially have our two factors. Once everything's been factored, of course, we make each one equal to 0, which was our next step as of yesterday. And to finish it off, do a little addition for this one, do a little subtraction for that one there. And so just like that, we have our two x-intercepts, which are represented by the number 9 and represented by the negative 2. Again, these are x-intercepts, aka zeros, aka roots. Remember, everything that we're doing can have a different name, but they all mean the same thing. We're trying to find x-intercepts in general. Now, that was the factoring technique. And this is what you had to do on last night's homework on Big Ideas Math. Then we look down here where we said, all right, I only see one x. This must be vertex form. And when I have vertex form, it is my goal to get that x squared all by itself. Well, then I'll start by adding the 8 to both sides. Isolation of the x squared is the first step we take. And just like that, look, on our first step, we already have the x all by itself, which is great. The only thing in math that gets rid of a power of 2 is to give it a square root, but just don't forget what we wrote in our note. Our answer for something like this means the square root, when solving, starts off with a plus or minus because we have two possible answers, and then the square root of 64 is just 8. And so this is when we usually split off our answer and we say x is equal to positive 8 and x is equal to negative 8. And what we just found right here, no surprise, we just found our x-intercepts once again. Remember, both of these techniques, we're looking for the same thing. We're looking for x-intercepts or zeros. But one way is if there's a single x, we use square roots. If we have more than one x, right, standard form, then we use factoring. So standard form uses factoring, while vertex form uses the square root concept. But now, here are the problems that we didn't get to yesterday. So I just wanted to refresh your memory there. So here we go. Example number 4. So we want to try some of these. Solve by square roots again. Well, notice we said solving by square roots only works if this is vertex form. Well, this is vertex form. But if you look at it, you might say, yeah, but there's a plus 2 on the inside. That's okay. My first step is isolate the parentheses squared. That's going to be my first goal, to get this parentheses here. I'm going to get this part all by itself. So if you look carefully, I can easily see what I need to get rid of right away. I'm going to add a 5 to both sides. Start off with that, just like we did on the other side. Now I know there's still a 2. There's still an x plus 2 squared, but now it equals to 14, and that's fine. My goal is to still continue to try to isolate this value right here. This is what I'm still trying to isolate here. So I'm going to divide everything by 2. The mistake that some people make is they think, oh, I should distribute. No, you're trying to get things away from it, not make it worse. So our twos go away. Besides, distribution can't work because of that power of two. So we end up with x plus 2 quantity squared is equal to 7. There. That's what isolation of a power of 2 looks like. This is when we can finally tell ourselves, right, now I'm going to give both sides the square root. So now I'm going to give both sides a square root. So I'll give it to this side here, and then I'll give it to this side here. But just like the last problem we did before, yes, I end up with x plus 2, but on this side, here comes that plus or minus, just like you saw previously. Now, square root of 7, that is not something I can take a square root of. It's also something I can't even simplify using the tree method we talked about. So then I get to leave it inside of the square root just as a square root of 7. But remember what we said. One of the things that we have to do now, this is when we split. We did that on the other side. We need to do it here. So x plus 2 is equal to radical 7, and x plus 2 is equal to negative square root of 7. Notice how one of them is positive, one of them is negative. And if it looks weird, I understand that. That's fine. You have to remember your ultimate goal is to get this x all by itself, which we finally can with one more step here. Look at that. Let's take away a 2. So we're going to subtract the 2 from both sides. And then now, if you thought that was weird, check this out here. According to our rules of radicals, I cannot take that. I can't say 7 minus 2 and actually subtract it. I cannot call this radical 5. When you have a value inside a radical of a square root and you have an outside value like the number 2, the rule is you can only combine them, the 2, if one of them has that radical 7. This is an inside number. That's an outside number. You really can't do anything. So here's the rule. The way you read it is the way you write it. It says radical 7 minus 2. Radical 7 minus 2, there's my answer. If you can't do anything with them, and you cannot, then the way you read it is the way you write it. I mean, look at this other one. Negative square root of 7, and then it says minus 2. Minus 2. Just make sure that 2 doesn't look like it's on the inside. So when you get these weird ones where it doesn't work out, well, that's fine. You're just going to write it out the way you read it. So let's give at least one more try. Well, let's do these two here. Let's see. Now, if you notice, my goal is to isolate whatever has a power of 2. Well, if you notice, it is by itself. So this one's ready to go. I am going to take the square root of both sides. There it is. Leaving me, of course, with p minus 4 here. And don't forget, don't take a square root of 49 yet. Make sure you're writing your plus or minus. Remember, we have 2 possible answers because of this power of 2. The square root of 49 is a perfect little 7. We don't need a square root like we did over here, right? This one does go away. But remember, this is when you split. So now it's p minus 4 is equal to positive 7. And then, of course, p minus 4 is equal to negative 7. Now we can do the work. I'll add a 4 here to both sides. Same thing here. Look, I'll add a 4 to both sides. And just like that, we have our new p-intercepts, because they're not calling it x this time. 7 plus 4 is 11. There's my first one. And over here, p is equal to negative 3. So just like that, we have our 2 intercepts for this quadratic. So let's try this one here, last one. When I look at this one, yes, I see that parentheses with a power 2, and that's my goal. I want to get that all by itself first, but I have to get rid of everybody else. So I'm going to add a 4 to both sides to begin with. So let's see what happens with this one. We end up with 3x minus 1 squared is equal to 9. All right, easy enough. Still not by itself, right? If I were to highlight this thing, Look at that. The 3 is still in the way. So then I'm going to divide everything by 3. The 3's are gone. X minus 1 squared is equal to 3. Again, you are not allowed to distribute a 3. That power of 2 doesn't allow it. But now I can get rid of that power by taking a square root of both sides. Don't forget, on the left, we have x minus 1. But on the right side, the first thing, you got to bring in that plus or minus. And here we have a situation where I cannot take a square root of 3. So then I leave it in there because I couldn't even simplify it either. This is where the split comes in. Always split at this point. X minus 1 is equal to the square root of 3, and x minus 1 is equal to negative radical 3. And just like that, we're ready to go. We're going to add our 1 to this side. Same thing over here. And if you can't officially combine them, and we can't, not for this one, we said the way you read it is the way you write it. Square root of 3 plus 1. There's my answer. Right here, x is equal to negative square root of 3 and then plus 1. Just make sure that when you're typing these answers into your computer, into your Big Ideas Math, make sure that that 1 is on the outside of the square root. If you leave it stuck inside, it's going to tell you it's wrong. All right, so take a moment to catch up with the note here. We do have one more to go, so just let's get ready for that one.